Flight Mechanics 3, just want to briefly talk about Euler transforms. So if we take our aircraft and we have its axis system x, y, z, then we might want to calculate a vector quantity along those directions. Okay. Now of course the aircraft reorients in space as it manoeuvres. So let's, just by way of an easy example, take the weight. Okay, always acts vertically downwards. We understand that the weight acts vertically downwards. But of course we've got this aircraft in an arbitrary orientation. So we have to have a way of getting from the weight vector being vertically down to the components of weight vector in the x, y, z direction. So you think we'll just resolve that weight vector into those directions. Fair enough, but we need a mathematically straightforward way of doing that, and one way of doing that is by Euler transform. Now the Euler transform can be used to transform any vector. I'm just using weight as a simple example. So with the Euler transform, you go from one axis system to another by rotation about one axis to form an intermediate axis, and you can have a sequence of any number of those Euler rotations as you want. Okay, so the roll axis, Euler roll is about the x-axis, the Euler pitch is about the y-axis, and the Euler yaw is about the z-axis. So if we start with the aircraft in this orientation, and let's just say we start with a pitch about the y-axis to form this intermediate axis system. Okay, we then have an Euler roll about the x-axis to form that intermediate axis system, and we then have the Euler yaw about the yaw axis to form that final orientation of the aircraft. Okay, so that was that particular sequence. We might have the Euler rotations in a different sequence, so let's say start with yaw, so we'll do that, and then pitch, and then roll. Ends up in a different orientation compared to the other sequence of Euler rotations. So at each Euler rotation we go from one axis system to the next. Well, each of those rotations has got its own separate matrix, which is the transformation matrix. So to go from, say, 3 Euler rotations, we multiply the 3 matrices together to end up with the final transformation matrix. Mathematically, it's straightforward. The individual transformation matrices have got nice mathematical properties, and the Euler transformation method is not without its disadvantages, gimbal lock being one of them, but nevertheless it's mathematically straightforward, it's intuitive, computationally straightforward, computationally simple. Okay, so that's Euler angle transformations.